transmitter, shortwave transmitter. So let me give you a taste of what it sounds like, and then we continue to build. All right. So I'm using this radio here. You can see we're on 89 megahertz. Sorry, 8.89. 8.9 megahertz. That's 8,000 kilohertz. Alright, so let's go and build. I'll show you what we did here. So right here you can see my transistor. I'm using a 2N2222. I have many 2N2222 transistor, many 2N2222 transistors. I got this pack, so lots of transistors there, so I can use for this kind of experiments. So that's my transistor. Then I have the 3-pin ceramic resonator. I showed you guys last time I was gonna scavenge from a board. So I scavenged one of them from this board from here. There's another one here for another experiment, and we're probably gonna use some of other components here for future use. But for now, let's just talk about this one here. So I'm gonna draw the circuit diagram. I have to make space. Let's draw the circuit diagram. The circuit diagram is a basic transistor amplifier like we did previously. We have the NPN transistor, and then at the gate we have first of all, at the collector we have a resistor. This resistor is 5K6. And then between the collector and the base we have another resistor, and this guy goes to the positive. We're using up to 12 volts. We've gone from 3 volts to 12 volts, and it works. All right, so we're gonna go 3 to 12 volts. We try to find out where it works best for you. And then we have one capacitor here, and then another one here. This is the antenna. All right, the emitter goes to ground, but try it in your own. If you want to build it, try to use the resistor here, 1K resistor. All right, but this is what we had. And then for the ceramic resonator, he has 3 pins. So we connected this one here, that one there, then the center pin we connected to ground. So but the reason I'm telling you to put your resistor is if you have the resistor around here, then the resistor can go to ground and the center will go there. But in this configuration we're testing today, the center pin went to ground. So the ceramic resonator is like this. So we did this connecting to one end, the other end, 1, 3, then 2 went to ground. That's how we connected it up to there. All right, so do that. This resonator is 4.5 megahertz. Right, connect it up like this, and then to bias, to modulate it, we connected a capacitor here, and then that capacitor goes to the audio input. So that's how we connected it up, and everything works fine. So try this. I'm gonna verify the value of my capacitor. So 10 microfarad, 25 volts. So for capacitor, I have 10 microfarads at 25 volts. Yeah, this resistor here is 56k. This capacitor here, I'm going to verify the value for you. So this guy here is 104. And then alright, this is the capacitor. I can't see the value yet. I think that's 47 picofarads. Alright, so is there another component here? No, we have all the components. Yeah, build this and let us know how it works for you. And then if you want to improve the range, of course you can put low pass filter to remove the harmonics, and then you can amplify it further. Right, so let's just listen to it again. Right, that is playing from a YouTube video, and then transmitted through our ceramic resonator, shortwave transmitter. As you can see, that's a shortwave transmitter, shortwave receiver. The actual frequency is around 445, something like that. So it's gonna be 4445. So that 8.8 8.9 is the first harmonic, the fundamental. Right, so trying to read the frequency using the oscilloscope, but it's not stable. I think this oscilloscope is probably not optimized for megahertz. It works well in kilohertz and all that. And this sounds better at a higher frequency. So if I go on 8.9, let's see. Sorry. Let's try increasing a little bit and see. Alright, so I think the better of at 8900. Let's double this. Okay, let's double this again. Alright, we can double it. There's the limit. There's the limit. If we double this, you're gonna be at around 35. But if we do that, it doesn't allow us to set it. Let's try 36. It doesn't let us set it at 36. No, yeah, that's the limit. Okay, let's just go gradual and see the limit of this range. It probably gets to 37, 27. Let me just jump to 27. F 2 7 0 0 0. Okay. I just want to see the limits of this receiver. So I was trying to double it again, but it doesn't let me get to 34. So, all right, let's see the limit. It's around, yeah, 29.99. Say 30. Yeah, that's the limit. Then the lower limit is 1.7. I see. 1.7 mega. All right, so let's get fundamental frequency. That is 4. It should be 4.5, but you can see it was offset a little bit. So let's get to that. 4.4 wasn't as clear as 8 though. All right. This is good, but if we double this 8.9, it's much better. 8900. Yeah. All right, you go ahead and build this circuit. We're gonna use it as a modulator for our TV transmitter. Right, so we feed audio, and then we'll take this guy. We're gonna build another circuit, maybe here on a separate board. We're gonna build the TV transmitter, and then take this audio transmitter as inputs to that low frequency, in with respect to the TV transmitter, which will be around 60 megahertz or so. We're gonna take this 4.5 megahertz as input, the audio input, to mix with the video signal, and then transmit and see how it works. So that's the whole purpose of doing this. Although we should have shifted the components so we can fit the TV transmitter properly, but we'll see. All right, so there's a circuit diagram again. People normally ask me, where's the circuit diagram? There is it. So this transistor is 2N2222. I'm going to level it now. So the transistor is 2N2222. Alright, we didn't use this resistor, but you can use it. And then for the center of the ceramic resonator, you're gonna ground that. That's what we did. But I'm saying add 1K resistor before the ground and see how that works. Alright, so probably that's what we're gonna do in the final version to see how everything works. I'm gonna level the crystal one more time. It's 4.5 megahertz. And then what else? Okay, I'm gonna level the pin. Okay, you already have the pin level. It's 1 here, 3 here, and 2 in the middle. So that's the pin. 1, 2, which is the center, and then 3 there. It's 4.5 megahertz. Alright, let me freeze my hand now. You can pause the video and copy out the circuit diagram. Alright, tech guy, hold your hand still. Well, now you can pause the video, right? Pause the video and build the circuit. Stay enthused, right? Stay creative. Stay creative. Alright, let me just disconnect. Let me disconnect the oscilloscope. Alright, remember to like and subscribe, share the video. Alright, I'll see you later. The audio quality is not bad for these number of components. Let me see how many components we have there. 1, 2, 3, 4, 5, 6 components. For 6 components, shortwave transmitter, not bad. So that's 1, 2, 3, 4, 5, 6. Okay, 7. 1, 2, 3, 4, 5, 6, 7. 7 components shortwave transmitter. Right. Make this your weekend project, and we'll see you in the next one. Like, subscribe, share. Alright, bye.